Hi ladies, in this video I'm going to do question 12, which is one of the more difficult questions in 5H. So this question actually refers to the golden ratio, and if you've never heard of the golden ratio before, it's basically a ratio that means things are pleasing to the eye. So when you find something really attractive or very nice to look at, then you would, sorry, my dog's just nudging my knee, then you'd call that the golden ratio. Okay, so if you're interested, you can look up the golden ratio if you like. It's something that actually exists. All right, let's get started on this question. So we've got a rectangle here. It's called the golden rectangle. What we've got is ABEF is a square, so you can see ABEF drawn there, and it's a square of length 1. Okay, so there's 1 on that side and each side is 1. And rectangle BCDE is similar to rectangle ACDF. So this rectangle on the right hand side here is similar to the bigger rectangle. What it means by similar is that your length and your width goes up by the same ratio or down by the same ratio. So think of a photo so a physical photo, and you wanted to get it enlarged. So if the width and the length went up by the same amount, we call that shape similar. Okay, it's not exactly the same, it's just bigger, but the photo itself hasn't changed, therefore it's similar. But if we, stretch the width of the photo so you had a really fat head or something, then it would no longer be similar. So similar just means it goes up or down by the same ratio. Okay, so if your width doubles, your length doubles, basically. And you can see here, we're going to be talking about the ratio because we're looking at golden ratio. This first part, question A, show that A over 1 is equal to 1 over A minus 1. So I'm going to start just by drawing. I'm going to use color here. Okay, I'm going to start just by drawing my diagram. So I'm going to separate this larger shape because it might just make it easier to see. Okay, so each side is 1, and that is the square ABEF. Trying to be very neat here. A bit sloppy with my drawings. Okay, and then we have this other rectangle at the end. Okay, so that's BC ED. And that triangle there also has lengths of 1. Okay, so they're 1 as well, and that's 1. But this side here, we might just look at in a second. So I'm going to now just draw the larger diagram. And I might just do that over here because I'm going to draw something in between a sec. Okay, so that's our full rectangle. So that's ACDF. Now this side on the bottom is A, and this is 1. Okay, so this side here is also A, and this one is 1. So basically, let me just go back and get my green pen. If this is A, so you can see A is here all along, and if this is 1, that means this side here is just going to be A minus 1. Okay, so the full length minus what we no longer have, which is the 1, so that's A minus 1. The reason I left a space here is because of this word similar. So at the moment, we've got like a rectangle standing in portrait mode, and then we've got a rectangle in landscape mode. So if I just change this green one to be in landscape, you can see they're similar triangles. So now this side is 1, this is 1, and this side over here is A minus 1. All right, I'm just going to scroll so we can see, maybe use a different color. Now, question A is saying we need to prove or show that A over 1 is equal to 1 over A minus 1. Now, remember when I said if you're enlarging a photo, let's say we're doubling it, we're increasing it by 2. Okay, so your length increases by 2 and your width increases by 2. or you're tripling it, you know, multiplying it by 3, or maybe you're making it smaller, so you'd be halving it, so you would halve the width and half the length. This is pretty much similar. We're just dealing with the letter A. Okay, so you can see here, this side here is A. So let's say that is A, and this side here is 1. So you can write them as a ratio. Okay, so this side here and this side here are what we call the similar side of that rectangle. And it's, let's say this is the bigger photo that we wanted to increase. So if we doubled it, that A would be 2. So it'd be 2 to 1. If we tripled it, it'd be 3 to 1. But we can also write ratios as fractions. So this is the same as A over 1. Okay, so remember, if we doubled it, if A was 2, that would become 2 over 1, which is 2. Or if we tripled it, it'd be 3 over 1, which is 3, etc. But we're dealing with the letter A. So that could be the length. Let's now look at the width. So now we've got 1 to A minus 1. Okay, so keep the sides the same. So we wrote the blue shape first and then the green. So we write the blue first and then the green. And then if we want to write that as a fraction, we put the 1 on top and then the A minus 1 on the bottom. Remember, these are just ratios. Okay, so the A over 1 tells us how much the length has increased or the width has increased, and then the 1 over A minus 1 is your other side. But they're actually the same amount, because remember, your photo, if you're doubling it, you don't want a very wide head, so you're increasing your length and your width by the same amount. So that is why the ratio for your length is the same as the ratio of your. All right, moving on to question B. Basically, we're going to be solving for A. Okay, so let's just move down. I actually did it before and I made a big mistake. So I've actually just deleted quite a bit of this video and I've started again. Okay, so we've got A over 1 equals 1 over A minus 1. Now, you're probably looking at it and thinking that doesn't look like a quadratic. So effectively, A over 1 is just going to be A. Okay, so we're just going to turn it into what you would normally see a quadratic look like. Okay, so A over 1 is A, and then 1 minus A over 1. Now, to get rid of this denominator, I multiply both sides by A minus 1. Okay, so they cancel out. I'm just going to scroll up. Yeah, the mistake I made before, which you can't see because I deleted it, is I didn't complete the square properly. So I couldn't leave it as that mistake. All right, so A squared and then A times -1 gives you negative A, and I'm just going to bring that 1 over. And now we've got a quadratic and it's equal to 0, so now we can solve for A. I'm going to now complete the square. This is where I made my mistake last time. Okay, so we keep the first two terms, A squared minus A. We add the coefficient of A, so that's -1 over 2 squared. And because we added it, now we have to take it away. And then don't forget that -1 on the end. And I'm just going to check that I haven't made any errors. Okay. I have faith in myself at the moment. All right, whatever you have in the bracket here is what goes, oh, you know what I did? I did this last time. That wasn't the mistake. I just need to get rid of that squared. I kept the square on. Okay, so A minus a half. That's all squared. All right, and then we've got -1 over 2 squared. So it's a negative, so it does become a positive. And then when you square a fraction, you square your numerator. So 1 squared is 1, and you square your denominator. So 2 squared is 2. Now, because I'm dealing with a fraction here, I'm going to turn that -1 into a fraction as well. And so it's going to be negative 2 on 2. So 1 is the same as 2 on 2. Just having the same denominator makes it easier to add your fractions. All right, so let's just tidy it up a bit. All right, so negative a half minus 2 on 2. So we've got the same denominator. So negative 1 minus 2 gives you negative 3. All right, and now we can solve using the difference of perfect squares. So I know we've already got a's, so let's use it. This is a different a, and I'm showing that with a different color. So a, when we're doing the difference of perfect squares, I hate using the same letter because this a is different to this a, but if you understand that we're doing the difference of perfect squares, that should be fine. So we're a minus a half, and then b becomes the square root of 3 over the square root. Oh, gosh. I've just noticed I've made a mistake because I knew that couldn't be there. Keep making mistakes. I'm not going to delete the video. I'm just going to keep going, deleting if you have noticed what I have done. Okay. So this should have been, oops, that should have been a 2. 2 squared is 4, making this hopefully you noticed that. Sorry about that, girls. Okay, so let's go back to this step. When I squared this, I squared the 1 and got 1, but 2 squared is 4. And then this one, I've just made the same equivalent fraction, but I've just written as 4, so we've got the same denominator. Okay, so then that becomes negative 5 on 4. And then over here, let's just tidy this up again, start again. Green. We've got the square root of 5, and then the square root of 4 is 2. Good. I think we're good to keep going now. All right, so the difference of perfect squares, we've got a minus a half plus root 5 on 2, and then a minus a half minus root 5 on 2, and that is equal to 0, because remember, it's an equation, not an expression. Oh, I've run out of room. Let me just do this quickly. So now your brackets, both of them are going to be equal to 0. So we're going to have a minus a half plus root 5 on 2 equals 0. Or this bracket, second bracket is equal to 0. So when we bring everything over to the left-hand side, our two solutions are going to be a equals a half minus root 5 on 2. Now, you probably should put that all over the same denominator, so I'm going to do that now. And then your other solution, and I might just separate it, sorry, at the end of the page, it's going to be 1 plus root 5 over 2. Okay, so there's our two solutions. All right, sorry girls about the tight squeeze at the end. All right, bye.